of the numbers, right? And it prints a dash everywhere else. So number one works. And so number two has a for loop, and it has two more for loops inside. So the first for loop inside prints a dash until I minus one. So if so wherever the number is supposed to be located, everywhere before that, it prints dashes. So um, that part works, and after that, it just prints 2 times I, and so that way it gets the sequence of numbers correct, and it prints dashes all throughout after the number. So number 2 works as well. And then for number 3, it does the same thing as number 2, except number 2 starts at k equals 1 for this for loop, and ends when k is less than 6 minus I, and this starts at I plus 1, and it ends when k is less than or equal to 6. So it's the same thing, but just with a different k. So 1, 2, and 3 work, so the answer to this one is E. 25. Consider this program segment. What is the true statement about the segment? So the first statement says if 100 is less than or equal to num, which is less than or equal to 1000 initially, the final value of new num must be in the range 10 is less than or equal to new num less than or equal to 100. So this is incorrect because if num equals 100, then the loop will only run once, and the value of temp will be 100 mod 10, and it'll be a single digit number, and so new num will be equal to new num times 10 plus temp, and new num will remain at 0, and so the value will just be temp, which will be a single digit number, and that's not between 10 and 100. So this doesn't work. Statement 2 says there is no initial value of num, which will cause an infinite while loop, and this is true because the num divide equals 10 will always produce a number which is less than 10, and once the number becomes less than 10, the while loop exits and it won't cause an infinite loop. So number 2 is true. Number 3 says if num is less than or equal to 10 initially, new num will have a final value of 0, and this is true because the loop will be completely skipped if num is less than or equal to 10, and so the value of new num will be the original value, which is 0. So number 3 is correct, and the answer to this question is D, 2 and 3 only. 26. Consider the method reverse. Which of the following replacements for code segment would cause the method to work as intended? So basically what this method does is reverse the digits in a number. So for example, 234 becomes 432. And so the first replacement won't work because when you have a number where the first digit is less than the number of digits minus 1, it fails to return the first digit of the original number at the end. So for example, if you have something like 163, then this first digit is missing from the reversed number. So this one does not work. And number 2 and 3 work as intended because they work by taking off the rightmost digit of n using mod, and they store that in rem, and then the current value of rev num is multiplied by 10, and the rightmost digit is added. So, and then when n equals 0, and so which means the entire number has been completely stripped down to no digits, rev num completes. So 2 and 3 both work, but number 1 does not work. So the answer would be D, 2 and 3 only.